guys, this is Miss Rainer, your handy-dandy physics teacher, coming to you today from C347 to talk to you about circuits. So, here we whoa, just kidding. Alright, let's get started. So, you can think of direct current kind of like mouse and cheese. By the way, you should be following along on your double-sided guided notes paper. We're going to start where it says day 1. So back to the mouse and cheese analogy. You have to think in terms of matter, and all matter is made of protons, neutrons, and electrons. The electrons and the protons are attracted to each other, and because they're attracted to each other, we get work that's done, kind of like a mouse and cheese. The mouse really wants to run to the cheese. Cheese can't run. All right. Another way you can think of the flow of electrons is it's kind of like flowing water. Water will flow from high to low. It'll flow downhill. So it'll flow from a place of high potential to low potential. And electrons are the same way. They'll flow from an area of high electric potential to an area of low electric potential. Okay. So we've got a couple of things to think about for voltage. Voltage is the amount of work a charge does as it moves through a circuit, and it looks like we'll be able to write those down for A and B on Roman numeral 2. You can kind of think of the voltage as the amount of push on the charges. So I've been talking to you guys about sending electrons on an obstacle course. That's how I think about a circuit. The electrons come shooting out of the battery with a whole bunch of energy. It's the voltage in the battery that gives the electrons that much energy. The current is how quickly they're running and how many of them are running. So it's the number of charges that pass a point in a certain amount of time. It's the rate of change of the motion of the charges, or how quickly or how slowly the charges flow. All right, here's a little bit more information about electric current. So this is going to go right next to rate of, and you'll write in charge flow past a point. It's measured in coulombs per second, otherwise known as an ampere. Sometimes we just say an amp. How do we make current? Well, we need a voltage. In order to have the charges flow, we need to push them along. How do they flow? Well, they flow at a rate of charge over a certain amount of time. All right, so let's look at voltage versus resistance. And we're moving on to Roman numeral 4 and Roman numeral 5 now. Voltage is about how much, kind of like quote-unquote pressure is pushing the charges along. Resistance is how difficult it is for the charges to get along. Resistance is exactly what it sounds like. That's what makes it difficult for the electrons to move along a conductor. So you have conductors that are very good at letting electrons flow, things like gold, things like platinum. You have things that are pretty good, things like copper, and you have some conductors that are not so great, maybe things like iron. And so there are some materials that have a lot of resistance in them, some of them that are pretty smooth. Okay, let's go on to electrical power. So here's A and B for electrical power. It's the transfer of energy. So power from before, you remember that's work over time. The amount of energy that can be transferred over a certain amount of time is the amount of power you have. You can transform that energy using a transformer. Okay, we're going to write down Ohm's laws now, and these go in the equation box. So Ohm's law has to do with V for voltage, I for current, and R for resistance. The voltage is in volts, the current is in amps, the resistance is in ohms, and we've got a couple of different laws to write down. Joule's law tells you about power. Power is current times voltage. And let's look at a couple of different ways to write these down. So here's a couple of different forms for power. You can use substitution, so you can write Joule's law in its original form, I times E. You can substitute voltage using Ohm's law, and you can write power in this form, I squared R. Or you can substitute for current in Joule's law using Ohm's law and write power in this form, V squared over R. Now we have some flexibility in our options for calculating the power through a resistor. So I want you guys to have a try at this power example, and we're going to have a look at this one and a few others in class tomorrow. Thanks a lot. Everybody have a good night.